So for those who don't know the nickname, that's the avatar. I had to do some patching because I work with PHP. I do some really, really ugly things with PHP. So they started calling me Gandalf PHP. So I did some adaptations. I work for a company called Rove. We are consultants. What is a consultant? A consultant is a person that comes in your company, takes all of your money, and then spends it on conferences. Yeah. So I'm pretty much like working and doing conferences. I'm part of the design framework team, so you can poke me if you have any issues there, you have any questions, you have any doubts, you want to help out. Ha ha ha, I have free work hours for everyone. I'm part of Doctrine, currently release manager on Doctrine ORM. Sorry for the slow releases. This is extremely defensive PHP. Extremely defensive PHP because I'm an extremist. Now, don't worry, I don't have a bomb, okay? Everything is going to be fine. I became an extremist in a good sense. I don't take middle grounds anymore when it comes to code. I feel that code should be written in such a way that you protect yourself from changes and from bugs as much as possible. So I became an extremist, and the problem is that while building software is cool, once you build it, you have to maintain it. And I build a new software project every weekend. I don't know if I'm stupid or something, probably. But I have too many projects, so I have to maintain too many projects. And these projects, they do too much. So I have many, many projects that were built without very strict thinking in mind, and you really, really feel the burden of maintenance. You have so many decision paths, so many different ways the software can be used, so many possible use case scenarios. You have to deal with all of them. So the problem is that everyone wants a nice, shiny feature. Everyone, this includes me as well. When I start on the weekend and I say, oh, this project, I want it to be so cool. It will do everything. Everything. It will make coffee and spaceships and explosions, whatever. Everything in one software. So we are all feature creeps. We all like creeping stuff into the requirements of our software. And this includes also the hobby projects, not necessarily just work projects. So this talk is about aggressive practices. If you are not building software that is supposed to last, like there are legit use cases where you don't care, don't apply these rules. These are for long-lived projects. You have a project that is going to stay out for years, then please consider applying them. Don't waste your time on the weekend project that is going to stay up for a month, okay? So if you are building open source, who is building any open source here? Few hands up, nice, well done. Thank you for helping out there. I'm sorry for the work you have there. But if you are doing open source, then you should probably adopt these rules. This applies, by the way, not just to PHP. If you're doing Java, C++, any object-oriented language, these rules apply. Any functional programmers here? Why are you here? You know this stuff. Yeah. So these practices apply to open source software because once you release open source software, somebody will use it, somebody out there, and you don't know for how many years this person will use your software. So you have to be proactive there because you may build a piece of software and in 5 years you don't even remember that you built it and you got an issue. There's a security issue in your software. And suddenly, because you don't get to fix it because you're currently, I don't know, on vacation or something, somebody's going to shit on your software. Because they say, oh, you have a security issue and you didn't fix it on time. So be very proactive when it comes to maintenance and reduce it upfront. So know your limits. This doesn't apply to everyone, and you also don't need to like these practices, and you can also call bullshit on them. If you don't like them, just feel free to say, oh, I don't like what that guy said. It's fine. These are my opinions. I'm just telling you what my opinions are here. But please be very considerate about what you release out there. Just because you have it doesn't mean that you have to show it to everyone, okay? I don't want to allude to something else, but really, don't release everything you write. There's no need. So let's start in a very bold way. You are dumb. Oh, I think that's the wrong, sorry, that's the wrong slide. No, I don't mean you, sorry. I am dumb. I am dumb, I'm a human being. I have a few billion neurons in my brain. It's a limited capacity. There is a computable capacity in my brain of how much I can memorize, how much I can keep track of. A human being can keep track of pretty much 7 things at the same time. And since I have some ADHD, I can keep track of 2, maybe 3, and then I start freaking out. So I have a very limited understanding of what is happening around me, what I have to deal with, what I did last week, what I'm doing tomorrow, and also the scope of the problem. I may not have analyzed everything correctly. I may have use cases that I left out when I'm building something. So we as humans, we are dumb. We are limited. We have some limited amounts of computational power. And we also have a limited amount of keystrokes in an entire lifetime, so keep in mind that, that as well. So everyone is dumb. Everyone has this limitation, and those who do not, I mean, everyone gets a dumb, everyone gets one, but those who do not admit it, those are probably the dumbest. You know, like there's people that say, you know, I'm the greatest, everyone likes me, I got the words, the best words, all that stuff, you know. There's people that think that. So, anybody know about defensive driving around here? Okay, I know we're in Poland, okay. I come from Italy, so it's not much better there, okay. But you got ice here, so I don't know. But anyway, the concept of defensive driving is driving, keeping in mind that you are not the only person that is going to make mistakes. Now, you may be the best rally driver in the world. You may be Colin McRae, okay? But somebody else will make a mistake, and you may have an accident because of that. So you always have to think about what may happen. A wild animal may cross the road, a football, an ice plate on the road, something like that. It's not your fault, it happens. So defensive driving is pretty much assuming that something else, somebody else will make a mistake, there will be something unpredictable, and it will mess with what we are doing. And defensive coding is pretty much like defensive driving. So you write some code and you assume that something or somebody is going to mess up. You know, you write code in such a way that everything that may happen, you consider it. Right? So you don't blow up a rocket that cost millions and millions of euros. I think that recently happened, by the way, like last week. So be cautious about everyone's code. And this means that you are not trusting the code. And everyone includes yourself. And it doesn't include the code you're writing right now, but the code you're writing tomorrow and the code you wrote yesterday. You yesterday and you tomorrow are different persons. Who remembers what, anybody remember what you wrote on Monday? What code you wrote on Monday? Come on, some hands up. Really, nobody? I mean, usually, if there's nobody, okay, that's perfect, but usually there is a couple, you know, that's fine. So we don't remember what we wrote or why we wrote it. Maybe you remember why, but not the details. So you have to always code in such a way that you forget what you wrote and you can still go back and have something valid and stable and secure and hopefully bug-free. It's not going to be bug-free. It's not going to be mathematically bug-free. But still, you're going to do your best. All right, some references. This stuff is not something I invented. I'm not telling you anything new. This stuff has been around since the 70s, right? So there's people that are probably already passed out that thought about these concepts. So the first reference I want to talk about is Code Complete. Code Complete is a book that I can recommend to everyone. It's a bit outdated in my opinion, but it has some decent coding practices, like don't abbreviate your variables. You know, we don't all come from a math background, so we don't call everything f, g, x, and y. Haha, functional programmers. And this book introduces some concepts such as keep a function's body smaller than a page on screen. Now, I disagree with that. A function's body should be like 5, 7 lines. Okay, but at least it introduced some of these concepts. So there, you can read it. It starts to introduce these concepts of maintainable code and code quality and so on and so forth. The other book that affected my career a lot even though I am a PHP developer, is this one. Effective Java. Effective Java is a practical manual on how to build bugs in Java. So this is a giant catalog of everything you can do wrong with Java, basically, and why, which is amazing. You go in there and you find like how you screw up designing exceptions, how to screw up an inheritance, how to have null pointer exceptions everywhere, and stuff like that. Okay, so that's for the references. Another thing that I want you to look up eventually is the concept of poka-yoke. Anybody speak Japanese here? That's good, because it's probably bullshit. But this means avoid mistakes. Poka-yoke means avoiding mistakes or foolproofing. It's an industrial design concept. Now, IKEA doesn't apply it very well, but Japanese people, they invented this concept which allows you to compose pieces of a structure in such a way that you can only compose them in one way. For example, take Lego. Okay, Lego, the toy. You can't connect two pieces of Lego upside down. There is only one way to connect them. It's designed so that everyone can learn how to plug them together. That's what poka-yoke means. So here's an example. This is an RJ45 cable, a plug. Anybody ever managed to plug this in upside down? There is always one. Yes. Yesterday, 2 days ago, I learned that you can plug a USB in an RJ45, which is also new to me. So, but anyway, it's really, really hard to plug it in upside down. And also, you see the direction immediately. So this has only one way of using it. This is decent poka-yoke, I think. Unless you make an etherkiller, which is basically connecting this on one side and the 220 volt on the other side. You plug it in, connect it to the switch, and you see the switches blowing up one after the other. Nice way to go from a last job. You know? Then there is something that is not so good as a design. This thing here. This is a device that exists in what I say a 4-dimensional space. So you plug it in, it doesn't work. Turn it upside down, try again, it doesn't work. So you turn it around again. Now there is some probably quantum physics, some warp, wormhole, something that happens, quantum lock, and now it works. So this is probably not such good poka-yoke design. Now they fixed it, they made USB-C, so now you can break the USB-C connector because it's so thin, but at least it works on both sides now. All right, other things that I need to make clear. Concepts that we all agree on. Code is reusable, right? I see a lot of nodding. No, code is not reusable. Don't reuse code. You do not trust code, remember? I told you not to trust code, so you don't take code and reuse it. Code is crap. Code is garbage. Any piece of code, as soon as you write it, it's legacy. Like 5 minutes after you wrote it, it is legacy. You have to maintain it. It is in your Git history. Even before you commit it, because when you have to commit it, you have to read through it and re-understand it. It's already legacy. You already have to understand your own code when you commit. So it is crap. And that goes with the Theodore Sturgeon theorem that 90% of everything is crap. This applies to literature. Pretty much you can go in any bookshop and say that 90% is crap. Pretty much. Good barbecue material. And if it is not crap now, it will be crap in 5 years. Anybody looking at their code from 5 years ago and say, oh, I'm proud of this code? Yeah, you know what I mean. Okay, what is reusable is not the code, it's the abstraction. So Peter Hitchens passed away recently. He was actually talking about protocols and designing protocols. Protocols and interfaces, abstractions, that is what is reusable. You trust the interface, the type system, the communication definition, how this code should behave from a description, an API. That is what is reusable. So in an object-oriented world, that is a type signature of a function or of an interface, right? The simplest way to put this is you have an interface. That is what you can reuse. You can share an interface, you don't share the code. So The quickest way to get rid of crap is to not write it in first place. So if you do not need a piece of code, don't write it. You ain't gonna need it. So what you need to do is you need to code for your current use case. Do not like go ahead and think about all the other 5 and 6 things that may happen. Just design one and make it work well. Isolate the scenario. There's only one thing. And then there's strategy patterns, design patterns to cover all the other scenarios. If you compose well, it works usually. So don't code for your reuse case. If you don't have a use case now, you're probably going to add stuff to your specification that doesn't really match what is coming up next. So you're designing something that you will have to delete in order to design again, and you may have some interface problems there. Okay, so now we talked about all these high-level ideas. Let's go to some good practices. I'm going to assume, and by the way, these are big assumptions. This is not a talk about like the typical solid principles. I'm going to assume that you already know what solid code is. Don't ask me the acronym. I can never remember it anyway. I know them singularly, but I can never spell out stuff. And I'm going to assume some object calisthenics. Anybody heard of object calisthenics? All right, a few hands up. So for the others, object calisthenics is, by the way, in the real world, it's an exercise, physical exercise. It looks like yoga. You're training your body to do some positions and training it to stretch over the limits and stuff like that. Now, object calisthenics is very similar. So you have a very strict set of rules about how you design code. So you can only have a certain amount of interfaces or classes per namespace. You can only have a certain amount of properties per class. You can have as much as 5, 10 lines of code per function. You can only have 1 indentation level per function. That's actually a hard one. Try designing everything with 1 indentation level, right? If you have a for each and then you have an if inside, you have to extract to a private method. So it's a lot of exercising and training and getting rid of complexity and stashing it away and hiding it into smaller isolated pieces of code. So it's a good practice, so look it up. It's interesting, but there's like entire talks just about that. And it's an exercise, you don't need to apply it strictly. First thing you should try to do, besides these practices, you should try to strive for immutability. Immutability as in state inside your objects doesn't change once you instantiated this object. This doesn't mean that you can make everything immutable, at least not in an imperative language. There are languages that force everything immutable, which is kind of interesting. You can try them out and see how far you get. But you have to strive for immutability. Anybody using the debugger regularly? All right, why? Don't you write tests? You know, in theory, you should use the debugger as little as possible. If you have a good test suite, in theory, you should have very little usage of the debugger. Still, what do you look for when you start the debugger? What are you looking at? What you're looking at is state. You stop at some stack trace point, and you're looking at the current state of the application. Because in a loop, this state changes, and you get confused. Like, why is this happening? Why is this becoming a 2 and it was a 1 before? Okay? When you start having immutable APIs, this goes away. Because you only have instantiation time setting of data, and you get rid of all this mutability. And this is a lot less to debug. To debug, there's a lot less bugs, okay? And you have much less cognitive load. You don't have to think about all these state mutations all the time. For example, PSR7 got this right. Anybody using it, by the way, PSR7? Yeah? I'm sorry, I'm always asking, it's fine. I just seeing how Poland is going along, you know, having an idea then. So PSR7 is a new specification for HTTP messages. It's basically what Java had 15 years ago. It's just that we got it like 2 years ago because we're so advanced. But still, they got it right. They have an immutable API, not fully immutable, but as much as possible. What about performance? PHP is not a language designed for immutability. It's garbage collected immediately, so you have a lot of overhead there. Still, the only way to measure whether immutability is going to make an impact is to profile. Profile and profile again. Use Xdebug, use xhprof, use Blackfire, whatever you prefer. you know, tideways, whatever. But you will only have problems with performance and immutability when your computational complexity is bigger than big O of log n. So you have a lot of iterations going on your data, right? So now we got rid of mutability. This means that we can get rid of another concept that is always breaking all our applications and making them relatively hard to maintain, which is setters. There is no need for setters. In object-oriented programming, now the more purist way of seeing it, objects talk to each other. They tell each other what to do. It's like inboxes. One object is sending a mail to the next object and telling, do this. And the other object says, okay or no. Okay, and then it says to the next one, do this. You don't go to somebody and tell them, you are now this. You tell them to do something, or you ask them something, but you don't tell them what they are, what they become. That's what we're doing when we design setters. So setters don't really mean anything. They're a concept that is kind of broken. We're exposing state, making it mutable from the outside. Sometimes they are legit. Some rare use cases are there, but still, try to avoid them as much as possible. When you get rid of setters, you can also reduce the instantiation of all the state of your object to the constructor. So your constructor becomes the only injection point. Careful, this doesn't mean that your user object has injection of services and stuff. There is a very clear concept of what an injectable is and what is not injectable, so careful about that. We're talking about injectables here. The constructor is the only injection point in this case. You don't have setters, you don't try to do property injection and all the stuff that some dependency injection containers do that is like really, really ugly. So since the constructor is the only initialization point, you do not have any uninitialized state. You don't have uninitialized properties where the property may be null at the beginning or some uninitialized state. You get rid of these properties with the state that you change at runtime. Now, this is something we used to do a lot. I'll show you an example in a bit. But we used to call it optional dependencies. So you have something like a database connection, and the database connection may behave in one way or another if you have logger or not set. We all did something like this. So we have a DB connection object, we have a constructor, and then somewhere we had a set logger. Now, forget the setter for a second. Let's say that we allow setters. What you see there is we construct a DB connection, and then later we set a logger. So this means that our object changes behavior after it is started its runtime, after its lifecycle start, which means that we can mutate it also in between steps of its lifecycle, which means more bugs. The other thing that may happen is that we don't even have a logger installed in our application, and then at runtime somebody decides, oh, let's add a logger, all right, because it's an optional dependency, and then it crashes because it can't find a logger. Now, in a statically compiled language, this would crash at compile time. In PHP, it crashes at runtime, so it's a lot more fun. Optional dependencies do not exist. You either have a dependency or you don't, period. Okay, there is no in-between. You're just adding more bugs for your users if you add optional dependencies. So there's a very quick way to solve this. You have a DB connection. You pass in always a logger. There's no setters. And then what you do is if you do not want to do the logging, you just pass in a fake logger. Relatively simple. And the logger does nothing. It logs to dev null, which is web scale. You can shard to dev null. All right. Now we reduce state mutations. We remove setters. Now what we need to do also, we need to reduce the amount of public methods as much as possible. We reduce the public API of our objects to the minimal possible API that makes our object work for the use cases that we have. To make this clear, unnecessary means that you can find another way to do it. The best way to find this out is to write a specification, like in bhat, for example, with Gherkin. You write when this, then this, and so on and so on. So you add interactions, you design them, and then you add the methods according to these interactions. And you will find it very natural to have these interactions on your objects. So you can find a different way. And the point is that you want to have very little public API, because a public method is pretty much like a child. Once you wrote it, you have to maintain it for the rest of your life, okay? So you can't add parameters that are non-optional. You can't remove parameters because somebody may rely on those parameters to be there. You can't remove the method. You can't add the new method to an interface. Careful about that. You don't add methods to interfaces. Every one of those mutations is a BC break, and it's going to make somebody angry somewhere, in your company or outside. So now we reduce the public API, but that doesn't mean that we have like very few methods and a lot of logic crammed into them. We don't add something called switch parameters. So don't start and have one method with 20 parameters, which is a bad idea. So one good example was the OpenSSL extension for PHP. It has now a new 7.1 feature, which is to be able to sign messages, sign ciphers. And it already had like something like 3 or 4 optional parameters, and they added another 4 or 5. You know, like, think about it. Now you have a matrix of all the possible combinations of the parameters. That's probably more than the atoms in the entire universe at this point. Yeah, what you can do with those. Probably not, but still, that's a lot of scenarios. So here's an example of what a switch parameter looks like. So we have a spammer. The spammer sends an email, renders a template, and then has an opt-out link. We want to send this email with an opt-out link or not. What happened here is that we are not exposing the actual intent that the developer wanted to show when designing this API. What happens here is that we have 2 methods. One is send illegal spam, and one is send apparently legal spam. Now, it's always spam, okay? It's not legal, period. Don't spam me. I got enough emails to deal with. But we extracted this parameter and made it part of the API. We made it explicit what we wanted to do. It's not like some hidden parameter. It's not like something that I have to figure out by looking at the documentation of the method. I have 2 different methods, very clear intent. All right. So we reduce state mutations. We reduce public API. We reduce access to internal state. Any access to the internal state should be protected from the outside, and the state should be encapsulated. You should be owning your state. Now I made another example with a setter to show how easy it is to build a bug. Does anybody see a bug here? I have a bank account, has a set last refresh with the date time. Anybody see the bug? Everyone writes code like this if you write setters. So you already have a bug in your code. Any suggestions? No? Yeah? Correct. So what happens is that this date time here is mutable. So now you have a reference that is taken from the outside world and copied into your object, but it's still in the outside world. So what happens is that, by the way, the examples are silly on purpose. What happens is that you have something like this. You have a current time, you create it, and you have a bank account 1, bank account 2, you set the current date on those. Another bug here, by the way. Then something happens, and 5 million lines of execution later, you change the current time. And what you got is a bug which is called a spooky action at the distance. That's what this kind of bug is called. So you have an action happening here and changing something over there. Now, in PHP, this is a bug. In CSS, this is how the language is designed. You know? Think about it. So it makes sense sometimes. I don't like CSS, but you know, it makes sense sometimes. There's a very quick fix for this. So what you do is you clone. You clone the reference. This actually dereferences. It removes a reference here. Or you use an immutable API. If you rely on immutable data, you can just pass it over, and it's fine. Right? And by the way, this can also happen in the constructor. You have the same problem in the constructor. So be very aware of what you're passing in. And prefer just type hinting against immutable APIs. It's much better and much simpler. Or a clone, you know. But we'll talk about clone in a bit. So external access includes subclasses. So subclasses are new classes that you design after you design the first use case. So now you have a new API, and what happens usually is that you want to use the base class as a means to share some behavior, which by the way is a bad idea, but still, we do it. And so what you should do is you should prevent state from leaking from the parent class into the child class. What this means in practical terms is that you do not use protected properties, ever. There is no point in using protected properties. For example, Zen Framework uses this everywhere. We have protected properties everywhere. It's a nightmare. We can't change anything inside Zen Framework because we are going to break everyone's code just because we add or remove a property or we change the default value of the property. We are breaking everyone's code if we change something like that. So now we're locked. We can't change a lot of classes just because there's loads of applications that rely on those. So don't use protected properties. Make them private by default. Right? Private properties by default. So other things that we should deal with. State mutations, any kind of state mutations, because you are going to have them. You should have any public method wrapping around the state mutation as if it was a transaction. Let's take another silly example. We have a public function add money and a public function mark bill paid with money. And how I'm going to use this is I'm going to call these two methods in sequence. This is pretty much where I would call them, like in a controller, in a service layer, in a command handler, whatever architecture you're using. What we will do is call these two in sequence. Now, what if the first method succeeds, but the second one throws an exception? All right? What if this object implements something like active record API? So every mutation you do on this object gets saved to the database. Now you got a problem because the second method failed, so you received the money in your bank account, but you didn't say that the bill was paid. So now you have an inconsistency, which may be good for your bank account, but not for your client. So you have one single interaction here, and we designed it as two method calls, and we may have a bug here. There's a very simple way to do this and fix it. You make the two other methods private, you don't expose them, and make one single public function, which is pay bill in this case, and this pay bill method will be responsible of catching exceptions and dealing with them and restoring previous state should something go wrong. So you have to be aware of that. Internally, your object may fail, so from the outside, you can't make sequential method calls. You may have problems there. So it also becomes easier. It looks better, right? Bank account, pay bill. Simpler. So you have a single API, and you wrap around state changes. Other things you should not do. Assuming method idempotence, everyone pronounces it differently. I'm going to ask around for opinions about it. So let's take an API that may resemble something from your framework of choice. So you have a controller, you get the request from the controller, which by the way, request is a parameter, should not be local state of the controller. But you fetch the request and get some parameter. Then you fetch the request and get some other parameter. This is perfectly fine, but there is no guarantee whatsoever. We are assuming that the request will give us the same thing over and over and over on every call. There is no guarantee of that. Nobody told us at the type system that this isn't creating a new request object internally. So we may have some problems there. If you have a date time internally, and you have microseconds now saved in the date time, you may have a bug because on subsequent calls, the date time is going to change. And if you're comparing them somewhere, you may have a bug. Very simple to fix. Just cache it in a variable. Get rid of this idempotence assumption by putting idempotence in your code. You now have one object, and you get data from it. And by the way, getting data from a parameter bag is not really a good API, but still. We are removing an assumption. You see the pattern there? Assumption equal bad. You know, if it's not in the type system of your language, then you can't really trust it that much. So try to design the API. Assertions. Any data that comes outside of your domain is basically insecure. You may not confirm your requirements. So anything you receive from the outside, and it looks a bit squishy, a string, an integer, an array, you need to assert over its properties, over its state, and see if it matches your requirements. So what you do is you enforce some strict invariants. If you want to receive an email address and you receive a string, you need to apply some validation, verify that it is actually an email address, and what you do then is you upcast it. Upcasting it how? You basically create an object that represents this email address object for you. In general, what you should do is in your API, first, for example, we have a train, and the train is built with a set of wagons. This is a silly example, just because I like confusing people. Is this confusing enough? Anybody trying to read it? All right. So what I'm doing here is I'm creating a function with a variadic number of arguments, and I'm calling it with a splatted array of the parameters here. So what happens is that I'm asserting on two things here, very subtle. I'm asserting, first of all, that every instance inside the array must be a wagon, so it can't be something else. And I'm also asserting that the array is only composed by keys, and the array key starts from 0. So there's a lot of assumptions there. So don't do this. This is horrible. Just wanted to confuse you because, as you're all falling asleep. You sure you had coffee? Yeah? All right. But use an assertion library. So if you use an assertion library, you get some nice exceptions, some descriptive exceptions. Just use them. But in general, you do not accept mixed parameter types. Mixed is pretty much your enemy when it comes to APIs, because it's a very, very low level of specification, and you don't know what to expect. So here's an example of what may happen in your system. In this case, we have a prisoner transfer request, and we approve it with a security level. Security level is mixed. This is something that happens when you have 3 generations of developers working on an API, and they keep adding more behavior to a value. So initially, it was just true and false. Then the manager came in and said, no, we need also these other scenarios, so they added null. And then they couldn't use null, true, and false anymore, so they started adding integers, and they said, okay, special cargo and high security. So you start adding more and more and more scenarios. This is a WTF barbecue. It's absolutely impossible to handle it, because you have this squishy value leaking through all your system, and you're really having a hard time tracking it. It's really simple to get rid of it. You just create an object. It's a prisoner security level. And this object will encapsulate this behavior, these rules that you defined. You see that we also removed the comment. The comment is also gone. We don't need this anymore. It's inside the specification of our object. We get rid of it. So value objects. Value objects for the win. Value objects are amazing. It's really, really simple. You just create an object, represents a value, but for you it's not just a string, it's a non-empty string. It's a non-empty string only of alphanumeric characters, and you call it username. And it now has a meaning, and you can type hint against it. And you ensure consistency, because you can't construct one of these objects with an invalid string. It will throw an exception. And you don't need to revalidate in every layer. This is one typical question. When you ask around and you say, where do you validate your data? And I get mixed answers. Somebody says in the front end and in the service layer and in the database. Everyone has an opinion on that. No, just throw it in the value objects and then eventually add it to the front end as front end validation so that it doesn't crash to the user. But what you can do now is that you create a value object, and here you have a function register with an email address, my email address. Feel free to spam me there. No, don't spam, sorry. I said don't spam, okay. And then in every other layer, you just type hint against this value object. You do not need to revalidate the data. You already have a type hint. And it also looks nice in your stack traces and in your debugger if you really need to debug. So the same goes for return types. Do not use mixed as a return type. When you show mixed as a return type, oh, by the way, there's seats in the front if you want to sit down. You don't need to stay on the door. Mixed is pretty much like showing the middle finger to your users. I'm serious, like, when you see an API that returns mixed, you're like, oh my God, seriously? Like, what do I have to expect? That's not useful. Use value objects again. One good example is the validation API from Zen Framework or Symfony. It's an old API, and we're not going to change it because there's lots of people depending on it. But the validation is usually something like validator is valid some value, and it will return you true or false, right? And then you have to say validator get error messages, and it will give you the last error messages from the last interaction. That's stupid. Return, instead, a validation result. And the validation result is a value object which contains, if it is valid or not, the original values, the filtered values, the valid values, the invalid values, and the error messages, and eventually the translated error messages, so you can have a lot of information in there, and it's all clean and nice and shiny for you. All right, gonna speed up here. Fluent interfaces. All right, Fluent interfaces, I'm opinionated on this, but I'm going to leave you with this. So we have a Fluent interface looks like this. It's the first one up here. And the other two examples are equivalent. All right, I'm not tricking you. These are 3 perfectly equivalent pieces of code. Anybody see the problem here? What is the problem with this piece of code? The problem is that this is not Poka-yoke. We went to Poka-yoke. There is only one way to make it work. So why do I have to have 3 ways of doing this when this works perfectly fine? Just make it work in one way. There is no point in having multiple ways of using the same exact API. Classes. I talked about code reuse. What we usually do is when we extend a class, we are reusing a piece of code from the parent class. Now, anybody using proper object-oriented design patterns knows that this is what you would do with composition. But, you know, we are lazy, so we extend. A subclass is a new design, a new use case of your code that you're solving. And it is a different use case, so you have to rethink it. And anytime the parent use case, the original use case changes, if you extend it now, you're probably breaking all the subclasses without realizing it. So there is a trick for that. There is a trick to understand whether you are using extends correctly or not. You take the class, strip it of all properties, strip it of all the method bodies, make it an interface. Okay, so now you take your class, you convert it to an interface. Now, does it make sense to extend that interface with your own interface? You think about it. It makes sense if you're adding some semantic meaning to that interface, then yes, extends is the right word. But if you're not, then you're probably misusing extends as a mean of vertical code reuse. So you have a problem there. Traits. Traits in PHP are pretty much compiler-aided code copy-paste. Code copy-paste is not necessarily bad per se, but code reuse is. Because imagine now you have 50 classes and you use the trait in every one of those classes. Now you have a bug in one of the classes, you modify the trait in order to fix the bug. There's no guarantee that you didn't break all the other 49. So traits are pretty much static coupling. You can refactor any trait into a static method on a static utility class. Really, you can take a trait and redesign it as a public static function somewhere, if it's a trait with one function. So don't use them. There is no point. Do you really need to reuse that code? Don't be afraid to open your editor, copy, and paste somewhere else. Do not be afraid of that. Copying the code manually and copying it over is fine. The dry principle, the don't repeat yourself principle of Solid is not about copy-pasting code. It's about not copy-pasting concepts and APIs. You don't want to have 2 APIs that do the same thing in your system, because then you may have a difference in the implementation of these 2 APIs, and therefore you have a bug because you made it work here, but the other way it didn't work. It's the same API, but it doesn't work the same because you have bug. That's where dry is. So be careful about that. Dry is not about copy pasting. All right, some other practical examples. Deep cloning. When you clone an object, at least in PHP, the state of the object is copied by reference. Any reference is copied over. So either you rely on immutable state, or you have the same problems that we looked at before, where you have the spooky action at the distance. You now have a new login request, you change something on it, and you change the original one. So you have to manually clone any reference that is mutable inside your object. But the other thing is that cloning is an operation that requires deep understanding of the encapsulation of the object, of the internals of the object, of how this object works internally. And PHP allows us to do this cloning on anything. We can clone anything. This is a contradiction. In object-oriented design, you should have a public function copy, because this object allows you to copy itself. So disable cloning, maybe. You can disable it by throwing an exception. You can also make it private function clone. And then you can still use clone in a private context if you're designing an immutable API, but from the outside you cannot clone, because the outside world doesn't know how to create a safe copy of this object. The same goes for serialization. Serialization is taking an object and generally putting it into a string. Could be a byte stream, could be a different thing, but serialization is copying from one format and moving it to a different format. This is not necessarily supported, because your object is not necessarily data, it's maybe just behavior. So is your object really serializable? Did you design it to be serialized? Do you know all the life cycle of all this, the internal components of this object? Anybody tried to serialize a PDO instance? You get an exception, right? Think about it. Does it make sense to serialize a socket? You can't take a socket, serialize it on one machine, copy it to a new machine, unserialize it, and make it work. It doesn't work. That's not how a socket works. Because it has a life cycle. So serialization breaks that life cycle, and PHP allows serialization on pretty much everything. So it breaks this idea that you only have serialization on some allowed things. So, and also, you don't have this assumption that all the objects have to be stored somewhere. Some objects are not supposed to be saved. So again, maybe disable it, throw an exception. This is, yeah, you can serialize it. Also here, you can make it private. So you can serialize internally to the object. You leave the responsibility of deciding whether it's allowed or not to the object. And the other things that you can do is that you can actually serialize only if it's serializable. If it's not serializable, don't serialize. All right, last stuff, okay. Unit testing. I'm from the old school. So what I do is I test all scenarios. All scenarios means both business scenarios, but also code branches for me. If I add a conditional, it needs to be covered, or otherwise it's dead code if there's no scenario covering it. So you have to test all scenario, all of them, and you need to bring the crop score below 2. The crop score, which I can't pronounce by the way, it's a ratio between the complexity, the number of code paths inside your methods, and the number of tests, which means that for every conditional, you have to double the number of tests that you have. That's a lot of tests. So you will really, really, really suffer from it. It will make you cry. It will make you implore to have less features inside an object and have more tiny objects that talk to each other, because you now can like split out responsibilities and test these in isolation. And you will love having less features, like when the manager says, oh yeah, we don't really need that. I just made it up. So let's make, the other thing that you can do is you should probably use mutation testing. Mutation testing is awesome because you can run it on an existing test suite. Anybody heard of Humbug? Yeah? Anybody used it? Yeah? All right, cool. Okay. Humbug is awesome. You just have an existing test suite. Run Humbug. There's no need for any modification ever in the test suite. You run it, and it will figure out if your test suite is shit. Right? It's amazing. It just figures out that you forgot to test some scenarios on its own. I mean, probably there's some mathematical way to define it instead of using humbug and trying random stuff. Still, it's quite awesome. Here's an example of how to test something in a more accurate way. So we have an interface, an out service, returns a Boolean, throws 3 types of exceptions, accepts some credentials. So that's relatively easy. That's the interface. And then we have some unit, which should implement an interface, but I skip on that, has a dependency on this out service, and has a login. Login accepts, uses the authentication service, passes in some credential, and then returns true and false. How many tests do I have to write here? Any guesses? 5. Yeah, pretty much. At least 5. The point is, there's a few things that can happen. A true is returned by the out service. A false, this is like done via stubbing. Invalid argument exception is thrown. You need to assert that it bubbles up. Same for the other 2 types of exceptions. And you already have 5 tests. And it's not just 5, by the way, because you also have these new basic credentials here, which is statically imported code. So you may have a problem there because you're statically coupling there. It's fine. You just have to consider that the credentials may be invalid. Therefore, you may have exceptions there too. So careful about it. So that's a lot of stuff. To recap, everything here is just suggestions. Okay? Now, if you feel like I was talking crap all this time, feel free to tell me. It's fine. You don't trust anybody's code. You don't trust the code, trust the interfaces, trust the type system, trust the specifications, and so on and so forth, but not the implementation. The implementation is buggy. As soon as you write down some code, you will have bugs in it, period. Even just by limitations of the engine. You want to reduce features to the bare minimum. You don't want features that are not necessary. If you are not going to need it, if you ain't going to need it, you ain't going to need it. Don't write it up front. You want to assert on stuff and upcast. So you have strict invariants, apply them, convert to value objects, and then pass around value objects. So you have the value objects as a guarantee, as an integrity layer between you and the outside world. You await strict, and you return value objects. Don't return mixed, don't return integer, and stuff like that. If it is a payment amount, then it's probably a positive amount, right? It's not like an integer. An integer is insufficient information. All right, that's all I have today. Thank you very much.